All right, welcome to Unit 1, Kinematics. And I'm kind of breaking it apart a little bit here. I'm going to have a vectors and scalars section, and then Unit 2. So on the website, it kind of shows up as this being Unit 1 and then Kinematics Unit 2. They're really all one and the same. So what we're going to do for the first 3 lessons here is we're going to look at vectors and scalars separate from the physics course. Make sure you understand that, and then we'll move into the actual physics concepts. Vectors are so important to the physics courses, especially for those that are looking at taking the 4U course. So what's your goal after this lesson? I want you to be able to compare a vector and scalar. So that's the first thing I want you to be able to do. And finally, I can use geometric properties of vectors to determine the resultant. Okay, so geometric properties, we're going to talk about what that means specifically. So what are vectors and scalars? All right. Scalars are something that you're most comfortable with because you use them most often. So scalars are measures that have quantity only. Actually, let's just go with, let's change that to have magnitude. And in brackets, I'll use the word size. Magnitude and size mean the same thing. So scalars are something that you're most comfortable with. So if you want to leave about the same space for vectors, I'm going to just list a couple of examples here below. So we have vectors and scalars, using all the space here. I'm going to put vectors, just making a bit of a t-shirt for ourselves here. Scalars, why are you most comfortable with them? Because this is what you measure all the time. So mass, volume, area, density from your grade 9 course, slope, okay, and slope's kind of on depending on how it's being used here. All right, so what's the difference? You ask yourself, then what's a vector? Well, vector is very closely related. They are measures that have magnitude, which is size. And then here's the thing that sets them apart. This is the and direction. Direction. Okay? So very important. Vectors contain both. So when I ask you to compare them on the first assessment, you can tell me that a scalar is magnitude only. Vectors have magnitude and direction. So what are some vectors? Well, weight is a vector, and we're going to talk about the weight and mass because they're interchanged and they shouldn't be. They don't mean the same thing. Displacement is a vector. Its partner is distance. How far did you go today? I went 100 kilometers. Okay, that's a distance. If I said, how far did you travel from your bed today? If you started at 8 and ended at, say, midnight, well, you would say, I started in bed, I ended in bed, so my overall displacement was 0. I ended where I started, so there is no displacement if I look at it in terms of the day. What distance did you travel? Well, you probably left home, you went to school, you then went to work, then you went to hockey, then you came home. And that's a measurement of distance, but displacement is how far you are from your starting location. So in most cases, everyone here probably has a displacement of 0 when they look at the full day. If you start in bed and end in bed, your displacement's 0. Velocity is a vector. Its partner is speed. Okay, how fast are you going? I'm going 80 kilometers an hour. What's your velocity? I'm going 80 kilometers an hour forward. All right, we assume that. We hope you're not going in reverse 80 kilometers an hour. Not with your parents' car. Acceleration, that's a new term. We're going to talk about it a little bit later on, but I'll put it in the chart because when you look back in your notes, you're going to say, oh yeah, I know what that means. So those are all examples of vectors. If you have to provide a direction, you are dealing with a vector. Okay, so there is a quick comparison between the two. Geometric vectors. So geometric is just a fancy way of saying drawing or pictures. Drawings of vectors or pictures of vectors. So terminology and notation. So what is a vector? A vector is a line that looks like this. So there we go. I just drew a vector. It has what we call a tail, which is the starting location. All right. It has a head, which is the end location. And the length of the vector is what we call the magnitude. So there's the magnitude of the vector. So there is our terminology. Now we can call this vector a couple different things. So off to the side is the notation. Vectors have what we call a harpoon on top. So if I wanted to call this vector vector u, the harpoon on top tells me that it's a vector. Okay, if it's not there, I assume it to be a variable. I can also name the tail of the vector, say that's point A, and you ended up at point B. I could also call this vector. I went from A to B, vector. So I put AB, tail, and head, and that becomes a vector. And then some of the old textbooks, I don't use this notation at all. You can go back to the letter, the U, but they use a bold face. The reason for that, in the old days, typewriters couldn't do the harpoon. It was very, very difficult. You had to do it by hand. So they had to have a notation pre-technology. So this one's really dying out in terms of where it's used. Okay, so there is our geometric or drawing of a vector. It's often, how would I get to, if you're going to give directions to someone, how do I get from high school to your house? You're giving them vectors. You're telling them go this way for 3 blocks, then you turn left and go. That's as soon as you give a direction, you are giving out vectors. So, what is a resultant? What is a resultant? A resultant is a vector that is created when 2 or more vectors are added or subtracted. All right, so it's a new vector. It's kind of like saying this is the result of doing the operations, or this is what it adds up to, the total. So resultant is kind of like a total. Now usually we use capital R to represent resultant. Okay, so capital R is the variable we use to represent resultant. Okay, with the harpoon on top again because it's a vector. All right, so let's do some adding and subtracting. Okay, so we have the vectors given here, and you have grid paper, and we want to determine the vector u plus v. So that tells me that I am looking for a resultant, and the resultant comes from adding my 2 vectors u plus v. So I have here steps. First, we redraw the vectors. With head to tail arrangement. Head to tail arrangement. So it doesn't matter what vector you start with. So you need to have, if you have a straight edge, it's great, but if not, you can kind of freehand this. So I'm going to take my u vector. Okay, I'm going to move it over here, somewhere where I have space. I'm going to take my v vector and do the same thing. And I'm going to arrange it with the head and tail, okay, lined up. So the u vector, think of it as directions. You go in that direction for so many steps, and then when you get to the end of my first direction, you now do this to get to your end location. That would mean our resultant would be from where we started to where we ended or finished. Okay, so that would be u plus v. So that's our resultant vector. So step 1, redraw the vectors head to tail arrangement. Step 2, draw the resultant. Starting at the first vector tail and ending at the second vector head. Second vector head. Okay, and then step 3, which I'll put right here, is determine magnitude and direction of resultant. And this may require trig. All right, and we'll get to an example like that. I started us off with kind of a simple one here. So if we look at our answer here, you went in the direction of u, then you went in the direction of v. So therefore, my resultant is, and just counting squares, 2 units long. And then you need to give a direction. So you could say to the right, r, or what I'm going to get you kind of used to is if that's north, then it would be east. Okay, so the resultant for this particular adding or subtraction is 2 units east. Okay, I'm going to do a couple more complicated examples and let you try some of these as you go along. So I'll stop this first segment here and then before I get into the next example.